This is the second video in a three-part series talking about equations of lines. Again, we had some errors that we made on our test we took last Friday. Wanted to try to correct those errors and created 3 videos to be able to do that. The first video was graphing equations of lines, and this second video will be coming up with equations of lines. So I want to move ahead and talk about that. One of the things that was on the test, I think, that might have confused some of you was this word derive. It says you can derive a slope-intercept equation of any line. Well, what does derive mean? Well, really, derive means that you can create a slope-intercept equation of any line. And you can do that if you have the slope of the line and if you have the y-intercept. You have to have those two things. That's why it's called the slope-intercept equation. So I want to show you some ways to do that. First of all, you might be given the slope and the y-intercept. Well, this is the best scenario that you could have. If they give you the slope and they give you the intercept, the equation is written pretty easily. Here's an example. Write the equation of a line in slope-intercept form given the slope of -9/2 and a y-intercept of 3. Well, again, they've given us the slope and they've given us the y-intercept, so it's pretty simple to write this equation. Remember, the equation is in the form of y equals mx plus b. That's the slope-intercept equation. M represents the slope. That's what they gave us there, -9/2. And b is the y-intercept, where it crosses the y-axis, and in this case that's at 3. All we really need to do is to substitute those two numbers into our equation and we're done. -9/2 has been substituted in place of m, 3 has been substituted in place of b, and that's our equation. It's as simple as that. Okay, another possibility is that they're going to give you the slope like they did in the last example, but this time they're not going to give you a y-intercept. They're going to give you another point that's not the y-intercept. So let's look at that example. Write an equation in the slope-intercept form that passes through the point -12, 13 and has a slope of 5/6. Well, they've given us the slope, which is m, but they did not give us the y-intercept. So we need to try to come up with a slope-intercept equation. Again, that equation's in the form of y equals mx plus b. We're going to use the slope to help us figure that out. The slope was 5/6. We're going to put that in place of m. So now we have y equals 5/6 x plus b. We're going to use this point, -12, 13, to help us figure out what our y-intercept is. -12 is our x value, 13 is our y value, and we're going to substitute that into this equation. As you can see here, the 13 is in place of y, the -12 is in place of x. Now we just have the variable b, so we're going to go ahead and solve for b. When we do this, 5/6 times -12 over 1 is equal to -60/6. That can be simplified down to -10. Now again, we want to solve this for b, so we've got to isolate b over here, which means get rid of the -10. So we'll add 10 to this side, which means we also have to add 10 to the left side. So you finally come up with 23 is equal to b. Again, the -10, the +10 cancel. So now we have our y-intercept, 23. We have our slope, which is 5/6. Now we can write our equation. Again, just like we did before, by substituting the slope in place of m and the y-intercept in place of b. Here's our equation. Y equals 5/6 x plus 23. Again, those are probably the two simplest ways of coming up with an equation y equals mx plus b. If they give you the slope, your job's halfway done. If they give you the y-intercept, it's all just substitution. They give you a point that's not the y-intercept. You have to do a little bit of work to find the y-intercept, but that can be done.